Alright, in this section we're going to do a bit of review of logarithmic functions. These are just sort of the definition and some properties of logarithmic functions and doing some algebraic manipulation. We're not going to get to derivatives until the next section, so if you're already really familiar and comfortable with logarithmic functions, you could skip this section. We're going to start with the definition. Log base a of x is equal to y if and only if a to the y is equal to x. It's the inverse of the exponential function, right? So you take your base, you raise it to this power on this side, and it gives you what's inside. Logarithms spit out the exponent. That's what they do. And of course, ln is an abbreviation for the log base e. So ln of x is equal to y if and only if e to the y is equal to x. From these definitions, we get these inverse properties. If you put an exponential function inside a logarithmic function of the same base, they basically annihilate each other. Log base a of a to the x is just equal to x. It gives you that power. And vice versa, a raised to the log base a of x is equal to x. What's important is that these bases agree here. And in item 2 here, we just have the same properties written out except in the natural base specifically. So here are some convenient properties of logs. One, we can split up a log. If we're multiplying inside a log, we could split it up as addition of the two logs. If we are dividing inside a log, we can split it up as subtracting the two logs. And I should mention that these properties work both ways, right? We could also use them to combine logs. If I'm subtracting two logs that are the same base, I could write it as a single log by multiplying inside. Same goes for that product in item 1. And then here's probably my favorite property. If I'm raising stuff to a power inside the log, then I can take that power, bring it down in front as a factor. So we could use these properties to rewrite logs. So in example 1.3, we want to use the properties, and it says expand the logs and write each as a sum, difference, or multiple of logarithms. So, all right, I'm going to do this in a couple of steps here. The first thing I'm going to do is just rewrite that radical. I know that the square root is 1/2 power, so the natural log of the square root of that stuff is equal to ln of 3x plus 2 to the 1/2. And it's just the argument that's being raised to the 1/2. It's not the log itself. So I could take this exponent down as a factor in front. So we have 1/2 ln of 3x plus 2. Next, we have a fraction inside. So I can see that I'm dividing inside. So the first thing I'm going to do is write this as a difference of logs. So I have ln of xy minus ln of 5, but now I have a product inside that log, so I'm going to split that up as a sum. Ln x plus ln y minus ln 5. Now with a scenario like this, a lot of times people will just go right from the start to the finish, and what we do is we take a look at everything is multiplied. You know, there's just multiplication and division in this log. There's no addition or subtraction. So any factors that are up top correspond to positive logs. Any factors that are on the bottom correspond to negative logs. Alright, now we're going to use these properties to go in the other direction. Here's an expression with 3 different logs. We want to write it as a single logarithm. And when we do this, the very first thing we take care of is any factors in front. We're going to raise them up as powers on the argument of the log. So I got ln of x plus 1 minus ln of x to the 1/2 minus ln of x squared minus 1. Now I've got a positive log here, right? That's a positive log to begin. And then I've got some negative logs. So for the negative logs, that's going to mean these factors are going to appear in the bottom of a fraction. So this is ln of, up top I have x plus 1. On the bottom I have x to the 1/2, which I'm going to go ahead and write as the square root of x, and then times x squared plus 1. These are both in the denominator because they're both negative logs up there. And now we're almost done. I mean, we wrote it as a single log, but we can do a little better because we can factor that x squared minus 1. If we factor that, it factors as x plus 1, x minus 1. And we can actually cancel that factor. So now we have ln of 1 over the square root of x times x minus 1. Now you can leave it this way. This is fine. Or 1 over some stuff is that stuff to the negative 1 power, and for that reason you can actually rewrite this as negative ln of root x times x minus 1. Either of these is fine.